Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday night math night. As you can see, I am struggling here a little bit. I don't know if it's the pollen or if it's just the sicknesses that are going around, but my voice is struggling. I feel like I've had this a lot more often this school year than I have in the past, and especially just in the last couple of weeks. So I apologize in advance. We are going to keep this one to like 30, 45 minutes. I know last week's was like 45 minutes too due to tech issues, but there is no way that this voice is going to make it for an hour. I'm going to start coughing up a lung. I've noticed I had to do a meeting today and I had to step out of the meeting because I can't talk for very long. But I didn't want to disappoint you. I wanted to be here for Wednesday night math night. So here we are. I hope that you all have had a good week. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do here. I love the community here and the spirit here. We are here to help you feel more competent and confident in your math skills because a lot of it is competency. You have to know how to add 2 + 2, right? You have to know those skills. But a lot of it is confidence too. If you're not confident in what you're doing, then a lot of times you're going to have that brain block or something that's hindering you from being able to execute that knowledge that's in your head. So that's why we're here. In the comment box, let me know where you're from, what test are you prepping for, and the get to know you question. This is always my favorite part because I get to learn a little bit more about you guys. So where are you from? What test are you prepping for? And do you like to cook at home or do you like to eat out? And that kind of seems like a silly question because like I feel like everyone would be like, oh, we like to eat out. But are you like let me cook a really good meal at home or do you like to go out for a nice dinner? obviously like money's not involved. We are definitely go out to dinner people. We love a good dinner out. We love meeting up with friends out at dinner. And so we are definitely eat out people. My husband is a very good cook and he does a lot of the cooking. But we are go out to dinner people for sure. I yawn a lot too with this because it's like, it tires my voice out. All right. So where are you from? What test are you prepping for? And are you a go out to school or go out to school? Goodness gracious. Are you a go out to dinner kind of person? Or are you a eat at home, like cozy, with family or watch a movie or something like that? All right. Enough about me. Enough about where you want to eat dinner tonight. Let's go ahead and get started with the first problem since we don't have much time together because this voice ain't going to last very long. Hello, Trina from North Carolina. What part of North Carolina are you from? I grew up in Cary, North Carolina. I don't know if you know where that is. Just outside of Raleigh. So yeah. And you're a go out to dinner kind of person. I love that. Hi, Barbara. It is good to see you. You're from Florida. Where are you in Florida? I'm in Florida. I'm in Central Florida. And you're studying for the FTCE. Exactly which one are you studying for? Are you studying for K6, pre-K through 3, 5 through 9, 6 through 12? Which FTCE, GK math? Which one are you doing? Also, I always like to have a next week section. So right here, I'm going to put next week. And if you have specific requests for the upcoming week, just let me know and I will absolutely include those in the upcoming week's sessions. You're in the Raleigh area. That's so cool. Very cool. All right, let's go ahead and look at the first problem together. GK. Problem 1, solve. Pretty straightforward. Okay, so this is definitely for my 6 through 12, 7 through 12 people. Don't shy away from this. Don't go running away if this is not something for you. I promise we have something for everybody. I'm just coming out of the gate strong with a 6 through 12 or a 7 through 12 problem, but I promise I have something for everybody. Okay, so solve log base x of 4x plus 5 divided by 6 minus 5x equals -1. So in order to solve for x, we really need to get rid of the log so that we can evaluate or simplify this section right here. So in order to undo a log, so this is for everybody, in order to undo addition, what do? Subtraction. In order to undo multiplication, what do? Division. In order to undo an exponent, we square root it or cube root it or whatever. In order to undo a log, we use a base number. I call it you big number it. That is totally not math talk, but that's kind of what I like to think about it. So I'm going to take the base, which is x, and I'm going to put an x right here. So x to the, and now all of this is in the exponent. And I'm going to do that to both sides. So now I have x to the -1 power. What that does is it gets rid of the log. And so I'm just left with what's in the parentheses. 4x plus 5 divided by 6 minus 5x equals x to the -1. But what can x to the -1 simplify to? X to the -1 can simplify to 1 over x to the +1, right? Now, this should look very familiar. This should look easy at this point. This first step was the hardest part. Now, I'm just going to cross multiply. So 4x plus 5 times x equals 1 times 6 minus 5x, which just turns into 6 minus 5x, right? So now I'm going to distribute this through. If you are an elementary person or a middle school person that does not have to know how to do logs, you need to know the distributive property. So like I said earlier, Every problem, no matter what I'm doing, I like to try to connect something for everybody so that it's not a waste of your time, right? So yeah, you don't need to do logs, but you need to know how to do the distributive property. You need to understand that the distributive property takes that factor that's outside of the parentheses and distributes it through. So let's go ahead and do that together. I'm going to rewrite this step just so that we can see it all. And then I'm just going to drop that 1 because it doesn't really matter. 6 minus 5x. So I'm going to distribute that x all the way through. X times 4x is 4x squared. X times 5 is 5x equals 6 minus 5x. Now I see I have a quadratic, which means I'm going to have to factor or use the quadratic formula to figure out what those factors or those zeros are because I'm solving for x. So I need to move all of this over. So add 5x to both sides. And I'm also going to subtract 6 from both sides so that I have 0 left over on that right side. So I'm left with 4x squared. 5x plus 5x is 10x minus 6. I'm going to divide out a 2. So pull a 2 out. And now I'm going to factor. 2, use my parentheses to figure out what those factors are going to be. It's really just 2x and x and 3 and 1. I'm going to put the 3 here and the 1 here. I know the 5 needs to be positive, so 3 times 2 is a positive 3 minus 1 creates a negative 3. So now I'm just going to set both of those equal to 0. 2x minus 1 equals 0. X plus 3 equals 0. So is the answer 1/2 or is the answer -3? That's the question of the day. The answer is going to be 1/2. Why? Because I cannot have a base of a log be negative. So when I solved this, I got a positive and a negative answer. The only plausible answer for this problem is x equals positive 1/2 because I cannot have a base that is negative. So the answer has to be 1/2. Questions about that? Comments, concerns? All right, let's go ahead and move on to the next problem. Which of the following shapes must have adjacent perpendicular sides? Which of the following shapes must have adjacent perpendicular sides? Square, quadrilateral, rhombus, rectangle, equilateral triangle. Square, quadrilateral, rhombus, rectangle, equilateral triangle. All right, so when I'm looking at this, and this is for everybody from pre-K through 3, all the way up to 7 through 12 need to understand the properties of shapes. So which of the following shapes must have adjacent perpendicular sides? Adjacent means next to each other. Perpendicular means intersects at a 90-degree angle. And then obviously sides mean sides. So if I'm thinking about a shape that has to have those 90-degree angles, does a square have to have 90-degree angles? Yes, by definition, a square has to have 90-degree angles. So check. And with those 90-degree angles, these sides right here are adjacent next to each other, and so they are perpendicular. Quadrilateral, does a quadrilateral does it have to have adjacent perpendicular sides? No, it doesn't have to have that. What it does have to have is 4 sides. That's the only property that a quadrilateral has. All it has to have is 4 sides. And so a quadrilateral does not have to have adjacent perpendicular sides. Rhombus. Does a rhombus have to have adjacent perpendicular sides? No, it does not. Is a rhombus always a square? No. Is a square always a rhombus? Yes. A rhombus has to have 4 equal sides, and those sides have to be parallel to each other. But a rhombus could look something like this with all of those sides being the same. It does not have to have those adjacent perpendicular sides. So already I see that all of the responses have 1, but I can cross out any of them that have a 2 or a 3. So B and C. So is it 1 only, or is it 1 and 4 only? A rectangle. A rectangle has to have those adjacent perpendicular sides. It does not have to have 4 equal sides, which is what distinguishes it from a square. A rectangle has to have those adjacent perpendicular sides, though. So my answer is going to be D, 1 and 4 only. I encourage you, if you are taking GK or K through 6, or even pre-K through 3, you must know the properties of quadrilaterals and what differentiates them. You just have to know, like, a square is always a rectangle, but a rectangle is not always a square. A square is always a rhombus, but a rhombus is not always a square. You have to know those kinds of things, and you have to know the relationship so well that you can play with it like that, because they're going to ask you these kinds of questions. Questions about what I just did? Let's go ahead and move on to problem number 3. Given the equation ax squared plus bx plus c equals f of x, which of the following does not affect the x coordinate of the vertex? Which of the following does not affect the x coordinate of the vertex? Increase the a value by 4, decrease the b value by 2, increase the c value by 3, or decrease the a value by 1. So when we look at this equation and we're looking for what does not affect the x coordinate of the vertex, how do I find vertex of a quadrilateral when I am how do I find the x coordinate of the vertex when I'm given standard form if it's not in vertex form? I could use completing the square. I can also do x coordinate of the vertex equals negative b over 2a. So I can take my b value and my a value, plug them in to that equation, and solve, and that will give me the x coordinate of my vertex. So which of the following is not going to affect it? Anything that I do to C. If I do something to A or something to B, it's going to impact that x coordinate. But if I change C, it's not going to impact the x coordinate of the vertex. It'll impact the y coordinate of the vertex, but it won't impact the x coordinate. So by increasing the a value, the b value, the a value, I'm not going to impact that x value. The only thing that's going to impact it is increasing that C value by a certain amount. All right, let's move on to problem number 4. Which of the following is equivalent to the expression 2 to the negative x power plus x squared? All right, this is a really interesting, good problem because it's not typical to what we normally, I feel like, see. This is definitely a 6 through 12, 7 through 12 problem. But I promise I have another K through 6 problem coming up. So I know that this does not distribute through. I'm confident of that. And I know that when I have a plus b squared, it's going to equal a squared plus 2ab plus b squared. If you don't have that memorized, you don't need to have it memorized. It's just something that I know. And I know that because I'm expanding a binomial like this, it's going to turn into a trinomial. So I know my answer is not going to be C or D because neither of those are trinomials. So now let's go ahead and expand this out. 2 to the negative x plus x times 2 to the negative x plus x. FOIL it out first, outer, inner, last. 2 to the negative x times 2 to the negative x plus 2 to the negative x times x plus 2 to the negative x times x plus x squared. Do you see how I got that? 2 to the negative x times 2 to the negative x. 2 to the negative x times x times 2 to the negative x, which just is the same thing. And then x times x is x squared. Now let's simplify. If I have a base times the same base with a different exponent, what is the rule? Add the exponents. So I end up with x to the 5th. Apply that same rule here. And I'm telling you, when I solved this problem, I literally wrote that out at the top of my paper so I could visually see it. So I have 2 to the negative x plus negative x. What's negative x plus negative x? Negative 2x. And then I know I have x squared. What do I have here? I have 2 times that item, right? Like if I have x plus x, I have 2x, right? So I have 2 of these things plus 2 times 2 to the negative x, right? Aren't these the same bases being multiplied times each other? So if there's an imaginary 1 here and I know that I'm supposed to add the exponents, what does that look like? X squared plus 2 to the negative 2x power plus 2 to the negative x plus 1x. Right? And it looks like I just have a typo. I forgot the little baby x right here. This is my answer. That was an interesting problem, wasn't it? All right, let's do one for my elementary people. Let M represent any prime number. Which of the following statements is true about M plus 1? M plus 1 is even. M plus 1 is not prime. M plus 1 is a whole number. M plus 1 is prime. Which of the following is true? So, this is a fun one. And Trina, I will absolutely go back. I'll finish this one and then I'll go back. Which of the following is true? So, what is a prime number? A prime number is a number that has exactly two factors. So 2 cannot be divided by anything but itself in 1. 3 cannot be divided by anything but itself in 1. 4 can be divided by itself in 1, but 4 can also be divided by 2. So 4 is not a prime number. 5 is a prime number. 6 is not a prime number because it can be divided by 2 and 3. 7 is a prime number. 8 is not a prime number. It can be divided by 2 and 4. 9 is not a prime number. It can be divided by 3. 10 is not a prime number. It can be divided by 2. And we could keep going on and on and on and on and on, right? 0 and 1 are not prime numbers because neither of them have exactly two factors. 1 has only one factor because it's 1 and itself, which is just 1. So 1 is not a prime number. So which of the following statements is true about M plus 1? If you are responding to this thinking that, oh, a prime number has to be odd, like 3, 5, 7, 11, 13, those are all prime numbers. If I add 1 to all of those, they are all going to equal even numbers, right? So M plus 1 has to be even. However, 2 is a prime number. So if 2 is a prime number, is M plus 1 automatically even? No. Is M plus 1 not prime? No, because in this situation, M plus 1 is 3 and 3 is prime. If we forgot that 2 was a prime number, then this would absolutely be true because M plus 1 is always going to be an even number if we forgot that 2 was a prime number. Is M plus 1 a whole number? Absolutely. That has to be true. All of my prime numbers are whole numbers, so all of my M plus 1 numbers are going to be whole numbers, right? Does M plus 1 have to be prime? Well, it is here, but in all of these other scenarios, it's not prime. So that can't be true all the time either. So the only true answer is D. Trina, why would it not be 4x? You mean here? That right there is not 4x because you have 2 to the negative x power. If I had 2x plus 2x, that would be 4x because theoretically you have 2 to the first power plus 2 to the first power, which equals 2 to the second power x, which equals 2 times 2 is 4x. So if I add my exponents together like I'm supposed to, as in that situation, I have 2 to the negative x to the negative x and to the negative x to the negative x equals negative 2 outside to the 2 to the negative x, and then you do negative x plus 1. Does that make sense? I hope that, I feel like that didn't make sense, but maybe it did. It's not going to be 4x because you don't have a exponent of 1. You have an exponent of a negative x power. That's why it wouldn't be 4x. I hope that made sense. If it didn't, let me know. All right. I've already coughed like twice or 3 times, and I know that this is only going to get worse as evidenced by like the pattern of how today has gone and the rest of the week has gone. So we're going to cut it short at 30 minutes tonight. Hopefully this will all be cleared up for next week. And we can do a full hour of all math, which is my favorite. I'm trying so hard to keep it down. And I feel fine. Like you can tell by my energy level, I feel fine, but it's just all right here. Let me know in the comment box what you want to see me go over in the upcoming weeks. This was a specific problem that somebody specifically asked me to review, as was number 6. So if there's something specific that you want me to go over, let me know in the comment box. And I look forward to seeing you guys next week. Have a great week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If Use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.